All right, this is going to be a video explaining 9C number 5. Okay, and remember, you may have different numbers than I do in this problem, so just remember that as you solve, but this will help you understand the method. Okay. All right, so in this problem, we've already got a diagram, but let's draw it simpler so that we can make sure it's super clear, our free body diagram. So here we've got our elbow, got our vertical bone, and our horizontal bone. We've got our hand here. All right. Now, the softball has a weight of 1.8 newtons. So it's got a force of 1.8 newtons down right here. Okay. And it's a distance 0.22 meters from our rotation point. Okay. Our bicep exerts a vertical force of 15 newtons. A distance 3.4 centimeters, so 0.034 meters from our elbow, from our rotation point. Okay. And we also have the force from our forearm itself. So we're considering that to be a uniform rod with a mass of 1.65 kilograms, and its center of mass is here. So there's a force M arm G there, and that distance is 0.11 meters from our axis of rotation. Okay. And the first question is, what is the net torque? All right. So let's consider the torque from each of these points around our elbow. Okay. So here, I'm going to write them in colors according to the ones that that I put in the diagram up there. So we've got first, all these forces are perpendicular to our radii, so I don't have to worry about the angle because the angle is 90 degrees, and so sine theta is 90 degrees. So first we have our 15 Newton force from our bicep, which is directed upward. That's tending to rotate the arm counterclockwise, so it's a positive torque. So that torque is a force of 15 newtons times a distance of 0.034 meters. Okay. Next, we've got the force from our arm. So here, this one's tending to rotate counterclockwise. So that's going to be a negative torque. We've got 1.65 kilograms times 9.8 meters per second squared. Let me scooch this over. Times the distance, which in this case is 0.11 meters. And then finally, we've got the torque from the softball. This one is also clockwise, which makes it a negative torque. So we've got minus 1.8 newtons times 0.22 meters. So when we add those all together, we get net torque of negative 0.45 Newton meters. So it's a net torque that is clockwise because it's negative. So this is a clockwise torque. And that's it for this video. See you next time.